Okay, so we're going to do a wrap-up recording on this program here, the hex to decimal. So what I'm going to do is, again, like the previous program on where we took text and changed it to numbers, this is quite a significantly difficult program, but it does actually bear quite a resemblance to the previous program, and for that reason you may find some things that are quite similar between the two. We're going to take it in stages. Firstly, we have to write a program that takes a string from the keyboard and tests to see if the string represents a hex number, i.e. contains only digits 0 to 9 and letters A to F. If it is a hex number, the program should print out the decimal equivalent, otherwise it should print an appropriate error message. So what we'll do first of all is we'll write a little bit of a program that figures out if it's got a hex number there or not. Okay. Now there's a previous problem that actually asks you to do that, so you may already have that done, but I'm going to include it here in any case. So I'm just going to hit pause for one moment while I write the bare bones of this program. Okay, so the first thing I want to do here is I want to create a string, or a character array, as it could also be called. That's all a string is, it's a character array. So character, and I'm going to call it str. Again, you'll notice that I probably use the word str a lot. That's just short for string, but it's not an important keyword or anything. It's just something that I've decided to use. I'm going to limit it to 10 characters, so I'm going to put in 10 there. What I'm going to do here is I'm going to do a printf and then I'll do a scanf, and we'll be looking for a %s this time because it's a string, and I'm going to put that in str. So we're going to take in the full string there. Okay. Now, what I want to do once I've got the string is I want to loop through each of the elements of it, and in doing so determine if each of the elements of it are a hex digit. Now, just to be clear on what a hex digit is, we have the following options. I'm just going to use one of my other classes whiteboards here, so just give me a moment. Okay, so hex digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then they go to A, B, C, D, E, and F. Okay, and if that would go away, I'll be able to see it. Okay, so A, B, C, D, E, and F. So there are 16 of them altogether, or 0 to 15. Okay. Now, what I want to be able to determine is whether it's one of those. Now remember, when it comes in as a character array, each one of these will effectively be letters, so we can kind of consider those to have single quotes around them. So it's the letter 3 rather than the number 3. And if we look at our ASCII character set, we can see that let's move down here a little bit. We can see here 0 has the number 48 associated with it. The letter 1 has the number 49 associated with it, and so on. So we'd want to be able to deal with ASCII codes from 48 up to 57 inclusive, and we'd also want to include anything from A here, which is 65, up to 90 inclusive, and also we could also accept lowercase. Oh, sorry, I shouldn't have said all the way up to 90, of course. We're only taking A, B, C, D, E, and F, so everything from 65 up to 70 inclusive. And we could also contain the lowercase ones, which would be 97 up to 102 inclusive. Now, as I mentioned previously to you, you don't actually need to know those numbers. You just need to be aware of the fact that they all come in sequence in our ASCII character set, and that's very helpful because we can then say bigger than and smaller than and so on in order to do it. So what I'm going to do is I'm going to make a for loop here, and I'm going to go for I sign 0, I smaller than 10. Okay. Now the reason I've picked 10 is that there are 10 elements in my string. Now I'm going to show you that making that assumption can be a little bit problematic, so we'll come back to that in a moment. So in my end program I'm not going to leave that there, but for the moment we will. Oh, sorry. Okay, so we're going to loop through this 10 times. Again, I've created I've used an integer called I there. I need to create that up here. Don't need to set that to any particular value because it's set the very first time it's due to be used here. What I want to do now is I want to check something. So if I want to check something, normally I use the if statement, and there are a number of things I want to check for. Firstly, I want to check if the current letter, which will be ST or I, is larger than or equal to, and we've seen that the number for the letter 0 was going to be 48. I could write in 48 here, but instead what I'm going to do is I'm just going to put in quotes around the 0, and that'll equate then to 48. So I want to see if it's bigger than or equal to 0, and it's important that we use the correct term here, and ST or I is smaller than or equal to a 9. Okay, so that's covered that range. So it could be anywhere between the 0 and the 9, but it could also be anywhere between the capital A and the capital F. So what I do then is I use the OR for that. Okay, now I'm going to go on to a new line here, because if I put 3 of these across the way, which I want to do, I'm going to go well across this important line over here, which means that it wouldn't print out if I was to put it on a printed page. So what I'm going to do is I'm going to place them right under each other here. So I'm going to say bigger than or equal to A, and just make a space there. Another OR here, because I want to also include this one. Now, sorry, I shouldn't put a semicolon there. I want to put an opening brace and then a closing brace for my if. Now, the important point about this is that what we've just checked for is to see if each letter is a correct hex digit, but in actual fact what I really want to be checking for is the opposite of that. I really want to check if any of them is not, because if any of them is not, I want to finish up my program at that stage, because there's really nothing I can do from that point on. I can't convert it to a decimal number if it's not a proper hex number in the first place. So if we take, for example, the number, and again I'll use my whiteboard here rather than write it on the thing. If I take A6F1, okay, that's a fine hex number, because the A is a proper hex digit, so is the 6, so is the F, and so is the 1. But if I had something like A6G2, okay, again the A is fine, the 6 is fine, the 2 is fine, but the G is not. The G is not an appropriate one, and that makes the whole thing a non-hex number, and so we need to remove it. So what I'm going to do is I'm going to check if any one of these is not true, and by that I'm just basically going to put that guy there, an exclamation mark in front of the whole lot here. I'm going to put an extra bracket just to be on the safe side, and an extra bracket at the end here, just to make sure that the whole lot is not true rather than just the first one here. So if any of that is not true, in other words, if it doesn't fall into one of those categories, the thing won't be true. So what I'm going to do at that point is I'm going to do a printf, say invalid hex digit. Now, unlike the previous program where you would have done this part of it, what I'm going to do at this point is I'm actually going to exit at that. I'm going to do a system pause. And then I'm going to do a return 1. Now, I had mentioned to you before, we normally do return 0. If we've got this far, it means that everything is run fine. We return a 0 to whoever called the program. Whether they interpret that or not is another matter. But if we return a 1, if they're interpreting these things, they'll realize that that came back as a failure. In any case, for the user who's using this, they will see this text come up. If we didn't put in the system pause, they wouldn't see that text come up because it would just do a return 1 and it would be gone before we'd ever have a chance to read this. Okay, I'll even include here system must exit. Okay, so what I'm going to do is I'm going to run that that bit of a program there, and I see I've put in 1 or 2 little errors, and we'll solve those as we go. So let's try a hex number, and we'll take the example that I had here, which was A6F1. And you'll notice that I've put in both uppercase and lowercase. Okay, and it says invalid hex digit, system must exit. Now, it may appear that that shouldn't happen because I've got A6F1 and all of those are fine, but it's telling me that there's an invalid hex digit somewhere in it and the system must exit. And this is where I mentioned earlier that the number 10 here is assuming that I've filled it up with 10 digits, but in actual fact I haven't. I've only used 4 of them in that example. So what I'm going to do is I'm going to run it again. I'm going to make sure to put in 10 of them. So 2, 3, F, 5, D, 6, 7, 9. How many have I got there? 1, 2, 3, 4, 5, 6, 7, 8, 2, C. And it's come up. Press any key to continue. So basically we haven't found any errors there in that. Okay. Now that's all fine well, but that restricts me to putting in exactly 10 characters. So I'm going to introduce something that you may not have seen before, which is the string length function. What we do, a little bit like the string compare function, if I pass a string to the string length function, it will return a number to me. Let's just see what number it returns. Three, 4, F, C, and you'll see that the string length is 4, so it's able to determine exactly how many of them we should check. You'll notice that it also come up with the invalid hex digit because we've got those extra ones. So what I'm going to do is I'm actually going to take that string length out of there and I'm going to put it in here instead of the 10. Okay. Now you may think, well, that this is saying smaller than 4. Is that going to work correctly? Well, it is, because there's 4 digits in that example that I put in, and that's going to go from 0 to 3, so that's perfectly fine. So 4, 5, C, D, string length is 4, and we also see press any key to continue because it's a proper bit of hex code. If I try one that isn't, if I put in F, 5, H, E. Okay, the H there clearly is wrong, and you'll see invalid hex digit, system must exit. Okay, so presumably then, if we have got as far as we are here, we know that the system is, we've got a proper hex digit into our system. So the next thing we need to start looking at is how we're going to change this to a decimal number. Now, that requires us knowing what each one of these values is worth. Okay. Now, the 0 to 9 are quite easy. They're worth 0 to 9. The A is worth 10. The B is worth 11. C is worth 12. D is worth 13. E is worth 14, and F is worth 15. Okay. Now, With that in mind, we need to know the position then that something is in. If I take an ordinary decimal number like 322, okay, we've clearly got two digits here that are both 2, but they're worth different amounts. 2 is worth 2 by 10 to the power of 0. 10 to the power 0 is like anything else to the power 0 is basically a value of 1, so that means 2 to the power of 1, or 2 multiplied by 1 is a value of 2. This one here, however, is 2 by 10 to the power of 1, which is 2 by 10, which is 20. 3 is going to be 3 by 10 to the power of 2 this time, because it's in that position, and that means that it's going to be 3 multiplied by 100, which gives me 300. And so altogether we've got 300 plus 20 plus 2, which gives me 322. We've proved not a whole lot there with that decimal number, because it was already in decimal. Okay. Just give that a moment now while it deletes. Clears up a bit of space for me. Now, what do we do with something like A6F1? Well, we've got to take this position here and say that that's 1 by, this time 16 to the power 0, because there are now 16 positions in our system. So that's basically going to be 16. F here is going to be 15, as we see here. So that's going to be 15 multiplied by 16 to the power of 1. Okay. Now, sorry, I've made a mistake in the previous one, so I'm just going to go back and delete that. Because I said 16 to the power of 0 was equal to 16, and of course it's not. So 1 by 16 to the power of 0 is 16 to the power of 0, the same as 10 to the power of 0 is just a value of 1, so that's basically just 1. Okay. This one, however, F is worth 15, and it's by 16 to the power of 1, which basically means you've got 15 by 16. Okay, now you can grab your calculator for these if you want. I've got one here beside me, so 15 multiplied by 16 gives me 240. Next one is a 6, so that's 6 by 16 to the power of 2, which is going to be 16 to the power of 2, first of all, I think is 256, is it? Until I just check. 16 squared, 256 indeed. So it's going to be 6 multiplied by 256, which is 1536, which equals 1536. And finally, A here is a value of 10. That's going to be 10 by 16 to the 3. Now, 16 cubed is 4096. By 10 is going, so that's going to be 10 by 4096, which is going to be 40960. So in the end, then what we do is we say 40960 plus 1536 plus the 240 up there plus the 1. And that comes out as 42,737. Let's just check that on our calculator, which you can do it on your own calculator at home, but what I'm going to do is I'm going to do it here on the calculator on the computer so that you can see it. And we'll put in hex, and our hex digit was A6F1, and in decimal that's 42737. So just as well, I hadn't checked it beforehand. Okay, so 42,737. So that's the system of how we go about it. But what we've got to do now is we've got to firstly determine each digit and turn it into a proper number that we're going to multiply by something. We've then got to determine where that digit is placed, because where it's placed is going to tell us how many times to multiply it by 16. Okay, just to make it a little bit worse, in our array, if we took in the number A6F1, this will be position 0, and this will be position 1, this will be position 2, and this will be position 3. Unfortunately, we'd like it the other way around, where this is 0, this is 1, this is 2, and this is 3. And worse than that, you know, we can have anything up to 10 digits, and we don't know how many we're going to have to start off with. So there are a lot of different complications with this program, so it's going to take quite some time to write. But take it in little small parts first of all. Firstly, what we'll do is we'll write a switch statement. Where I'm going to take in digit. Okay, I'll actually call that hex digit. And we'll have each of our cases. So we'll have case, so the case for a 0, which is basically just going to be that we're going to have the value equal to 0. Now I'm going to have to create some of these ones up here as I go. In the long run, the actual hex digit one here may not be required. We probably will just use the STRI, but for the minute I'm going to leave it in there. So I'm going to put in a value, an integer value called value, and I'm going to put in a character called hex digit. We'll continue on then to write this. No, I spotted a mistake I made there. That's supposed to go the other side of that. Okay, because what you're saying is you're saying this case, and then you put the, not a semicolon this time, obviously a full colon. Okay, and then we set the value equal to that, and we have a break. Okay, and we continue this down the way for each of the possibilities. So what I'm going to do is I'm just going to pause there while I build this up, and then we'll come back to it. Now, so that's the switch statement finished there. As you can see, I've gone through 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I've dealt with a capital A and a small a together. They're given a value of 10. Capital B and small b together, they're given a value of 11. 12 for C, 13 for D, 14 for E, 15 for F. We have a default condition, which is what happens if none of the previous are satisfied. That shouldn't occur because we shouldn't be able to actually get to this point without that happening, but that's not to say that something else won't go wrong. So what I've put in a printf here is to say something has gone badly wrong, just to make us aware if we've managed to get to that position. It shouldn't happen, but you never know that you wouldn't change something else to cause it to occur. Now, the trouble with any switch statement is you can see the length of it there, so it's normally nicer if we can put that in a function. I might well do that later, but for the minute I'm going to leave it in there so as not to complicate the situation. Now, what I'm going to do is I'm going to put a for loop around this, and the for loop is basically going to be the exact same as the one here. I'm not going to put this in the previous for loop, because obviously the previous for loop was just to determine whether everything was correct. And of course, because I'm putting this inside in a for loop, I need to tab all these in. I'm going to pause just while I'm doing that. Okay, and that's them all tabbed in there, and they're all inside in this for loop. And what I'm going to do is I'm actually at this early stage, I'm going to change that hex digit. I'm not going to bother using it. I'm going to use STRI because as we go through each element of the string, that individual character will go in there. I could just set STRI equal to hex digit and so on and do it that way, but I'm going to leave it this way. So what we're going to do is I'm going to put a printf down the bottom of this just at the very end to just do a new line each time. Just for the reason that what I'm going to do is I'm going to print out the current hex digit which is percent C. I'm going to leave a space there, and actually what I'm going to do is I'm going to do that at the end, because obviously I want to change the value, so I'll just put it down here. May as well put it all into the one here. Percent C. I'm going to leave I'm going to do a /t to tab it out, and then I'm going to do a %d. Okay, and you'll see in a moment why. So what I'm going to do is I'm going to do stri, comma, value, so that we see if it's correctly interpreted. Now this isn't strictly speaking part of the end program, but it's one of those places where as you go along and making the program up, building the program up, you should put these little parts in order to figure out what you're doing. Now please enter a hex number. I'm going to say 56CF3, and we can see that 5 has come out as a 5, 6 has come out as a 6, C has come out as a 12, F has come out as a 15, and 3 has come out as a 3, so that seems to be working exactly as we wanted to do. Now, within our loop, what we now have to do is use the information from the string length to determine each digit, how much it's going to be worth. Okay, so as we come around at the bottom of this for loop, we need to take the first element. Right now, what I'm going to do is I'm going to hop over here to my whiteboard and just maybe take a bit of a closer look at what we're going to do here. So we're going to call this str. This is my str array, and I'm going to put some values into it. So I'm going to say 2f3b1. Put little squares around these. Now, this is in position, so we'll just call this I value. Okay, so position 0. This is 1. This is 2. This is 3. This is 4. Okay, now obviously that can change as we go. For this one, string length strlen would be equal to 5. What I would like is for my first value here, I'm going to call this one power. So, so 16 to the power of. I'd like this one here to be 2 to the power of, well, what should it be? This should be to the power of 0, this should be to the power of 1, this should be to the power of 2, this should be the power of 3, and this should be the power of 4. So what I'm going to have to do is I'm basically going to have to make a variable. Basically, we can use our string length here, which is going to be 5, and I want to take 1 away from it to make it 4. What I should also do though is I'm also going to take away I from it. Now I is 0 in the first case, so in this first case that's going to become a value of 4. Okay. What happens in the next case? Well, if I say string length again, which will be 5 minus 1, which that stays constant, and then take away I. This time I is a value of 1, so it's going to be 5 minus 1 makes it 4, minus I will make it 3. Okay, and the whole point about doing any of these things is to try and keep it as general that you can put down one thing so that you don't have to be constantly rewriting different things. So again, this is going to be string length is going to be 5, and remember that 5 just happens to be in this case. The string length might be something else in another case. Always take away 1 because of the fact that string length will tell us that there are 5 digits, but we want to start at 0. And we'll take away I again here as I goes up, so that'll take away 2, so that'll now leave us in position 2. So that's what we're going to use in order to determine how to get the power of something, or what power to give it. The other thing then, of course, is that how do we raise something to the power? Do we just multiply it a number of times, or is there a function? Well, there's a function in the math.h library, and it's called pow, P-O-W. And what we do is we pass it two numbers. We pass it the number and the power. In our case, we're going to be the number that we're going to pass is going to be 16, and the power is going to be, we'll just call that power. And of course, what we're going to do is we're going to multiply this by value. Sorry, multiply. So whatever we get there, 16 to the power of that, multiplied by the value, and that'll do the job for us. So what we're going to say is we're going to say so the value that it does multiply by POW times 16 and then POWER. Now what's power? Well, we need to calculate that. We need to say power is assigned strlen string length of string minus 1. Okay, and it's also then minus I, which is the current value. Okay, so that'll calculate that for us. That'll put it into power. It'll be multiplied by value. What are we going to do with it? Well, for the moment I'm just going to print it out and see what we get. So printf. Actually what I'm going to do is I'm going to include it in my previous printf, because that's the handiest way to do it. So I'm going to Control-X and I'm going to put it here. So for the minute all we're going to do is print it out. Let's have a look. Doesn't like that. Oh yes, that's because I haven't declared power up the top. So another integer called power. And I've gone and left my semicolon in here. Now let's go back to the example that we had, which was in hex here, was A6F1. I've deliberately used both uppercase and lowercase there, and we don't appear to have printed anything out here. So we've got A is 10, 6 is 6, F is 15, and 1 is 1. So I've obviously left something out here. Oh yeah, of course I did. I didn't do a percent %D, so this didn't get put anywhere. So we'll run it again. A6F1, and right, we clearly have a problem here. So we've got A is 10, 6 is 6, F is 15, and 1 is 1, but we're printing absolutely nothing here. So we'll just take a moment to figure out exactly what we've gone and done wrong here. Okay, so the error that I have there, I have to pause there to find what it was. It took me a few moments. It's not an obvious one, but this power function here, when it's actually written in its file, is written as FLOAT POW, and then you can send either floats or integers. I'll write it here as an integer x and integer power, like that. So the point here is that this function is going to return a float and not an int, and what I have done over here, back here, is I've expected an integer to come back. So it's coming back on a floating point number and giving me the wrong thing. So if I change that to an f, that solves that problem. Okay, not an obvious one. I'm sure if you came across it yourself, you'd be a long time solving it. So again, just put in the thing A6F1, and we can see there that the A is 10, and that's going to be 40960, 1536, 240, and 1. And they're the numbers that we came up with earlier. Back here, 40960, 1536, 240, and 1. What we have to be able to do, though, of course, is to sum them all up or add them all up. So what I'm going to do is I'm going to make a float here called total. And what I'm going to do is I'm going to say C total is assigned total plus that. Okay, so I'm going to add this in each time. Hopefully at this stage you're screaming at the screen saying, Sean, you forgot to do something. And the thing that I forgot to do is I forgot to set this to 0, because of course if there was any sort of spurious information in there, we'd be adding it into our total, which we don't want to do. I'm not going to print out the total with this lot. I'm going to print it out at the very end, because obviously there's no point in printing out the total as we go along. So printf value is percent, and I'm going to have to use an F here. I could change it to an integer if I wanted, but let's give that a go. And so the total is 42737, which indeed is correct. So we'll just maybe come up with something a little bit more complex. 2CEA48F. Okay. So the decimal number for that is 47096975. Again, we'll go back to hex and we'll run our program. Calculator up here beside us so that we can see it, and we'll say 2CE. I'm deliberately going to use both uppercase and lowercase. A F8, or sorry, 48F, and that comes out as that. And just to hit the decimal, and we see that the two are the same value there. 470969. 76. Interestingly, we've got a slight difference in the values here, and I don't know if that's because I've put it in slightly differently, or if it's a roundup error. My suspicion is that it's a rounding up and rounding down error. So we can see there we have 2CEA48F. No, so we've definitely put in the same thing. It's merely a matter of a roundup error as regards what's happening. And roundup errors are to do with the physical size, the physical value that you can put in for a floating point number. For the smaller numbers like 2 and 12 and 14 and even 40,960, it can do that exactly. But some of the other numbers, some of the other larger numbers, it won't be able to give the exact number, and that's why we may have something slightly out there. That's what I assume is wrong there. But in any case, we're fairly close there on the value. Okay. Now. So that's it for that program. As I said, you could take that switch statement, put it into a separate function or something like that. But other than that, that's what you do. Again, like the previous wrap-up lecture that I've done, this is quite a complex example, and there's a lot to be done in it. But if you break it down to some of the some of the different elements to it, they're all eminently doable. It's just a matter of whether you try each of them out individually, such as using the switch statement here to change each of them into their proper values, and that most of you would be able to take a good stab at that. This section down here, trying to get the power and so on, that's considerably difficult. It's not the only way of doing it either. You could rather than use the power function, you could actually try and multiply 16 by itself that number of times and so on. You could effectively implement that yourself, although the power is certainly the easier way to go about it. But as I say, this is a significantly difficult program for you to tackle, so hopefully you've learned a little bit from the wrap-up lecture. Okay, I'm going to leave it at that.